Hello there, and welcome to Earth's History, where we ask the questions that keep you awake at night, where we explore possibilities that challenge everything you think you know about reality, where we contemplate whether our entire existence, our struggles, our triumphs, our civilizations, our very lives might be part of an experiment designed by intelligence far beyond our comprehension. Tonight, we're venturing into one of the most unsettling and profound questions humanity has ever confronted. What if Earth is a test? What if we're not living on a random planet that happened to develop life, but inside a carefully constructed experiment with parameters, controls, observers, and objectives we've never recognized? What if every challenge we face, every crisis we navigate, every choice we make is being monitored, recorded, analyzed by entities, testing hypotheses about consciousness, civilization, morality, or survival? If you've ever felt like reality is slightly too perfect to be accidental, if you've wondered why Earth seems positioned precisely where life can flourish, if you've noticed that human history follows patterns of challenge and response that seem almost designed to test our adaptability, if you've sensed that we're being observed or judged by something beyond our perception, you're touching on a possibility that science fiction has explored, but that has uncomfortable grounding in scientific and philosophical reasoning. The test hypothesis isn't just paranoid speculation, it's a legitimate framework for understanding why Earth has the properties it does, why humanity faces the challenges we face, and what our ultimate purpose might be in a cosmos that seems indifferent, yet somehow arranged around our existence. Wherever you are right now, I hope you're comfortable, settled, ready to question the nature of your reality and your role in it, ready to consider that your life might have meaning and purpose beyond what you've imagined. Not divine purpose necessarily, but experimental purpose. The significance of being a data point in the greatest scientific study ever conducted. Maybe you're lying in bed wondering whether your choices matter in a vast, uncaring universe. Maybe you're contemplating whether there's a reason for human suffering and struggle. Maybe you're ready to confront the possibility that we're not alone, not random, not purposeless, but observed, evaluated, tested according to criteria we don't understand, by intelligences we can't perceive. If this exploration into the test hypothesis changes how you see your challenges, if it gives you a framework for understanding human history's arc, if it makes you wonder whether you should live differently, knowing you might be observed, I'd be grateful if you'd like the video, subscribe to the channel, or share it with someone else who suspects there's more to reality than mainstream. Narratives acknowledge. So settle in. Let your breathing slow like a test subject relaxing in an observation chamber. Let your mind open to possibilities that sound like science fiction, but that might be science fact. And let's begin our investigation into whether Earth is a laboratory, humanity an experiment, and our entire history a carefully designed test with stakes we're only beginning to comprehend. The hypothesis: Earth as laboratory. Let's start by clearly articulating the test hypothesis in its various forms. What exactly do we mean when we suggest Earth might be a test? The basic premise: Earth is not a naturally occurring planet where life arose by chance, but rather a deliberately constructed or selected environment designed to test specific hypotheses about life, intelligence, consciousness, civilization, or other phenomena of interest to the experimenters. This breaks down into several sub-hypotheses. Hypothesis 1. The controlled environment test. Earth is a controlled laboratory environment where conditions have been precisely calibrated to allow life to develop. The experimenters set initial conditions: planetary mass, orbital distance, atmospheric composition, presence of moon, magnetic field strength, then observed what would emerge. We're living in a carefully tuned terrarium, a cosmic petri dish where the parameters were set billions of years ago, and evolution has been running since, with experimenters periodically checking results. Hypothesis 2. The civilization stress test. Earth and its challenges: resource scarcity, climate variability, disease, natural disasters, competing nations, are specifically designed to test whether intelligent species can develop civilization, cooperate globally, manage technology responsibly, and survive self-destructive tendencies. We're being evaluated on our ability to navigate existential risks: nuclear weapons, climate change, artificial intelligence, bioengineering. The test question is, can this species achieve technological maturity without destroying itself? Hypothesis 3. The moral laboratory. Earth is a testing ground for moral and ethical development. The experimenters are interested not in our technology, but in our values, choices, treatment of each other and other species, capacity for compassion, justice, cooperation, and wisdom. Suffering and injustice aren't bugs in the system. They're features, deliberate challenges designed to test whether conscious beings will choose good over evil, cooperation over competition, long-term sustainability over short-term gain. We're being graded on our moral evolution. Hypothesis 4. The consciousness incubator. Earth is designed to produce and test consciousness in various forms. The experimenters are studying how consciousness emerges from matter, how it evolves in complexity, what varieties of awareness are possible, how subjective experience relates to objective physical processes. Every organism's consciousness, from bacteria to humans, is data. We're not being tested on anything specific. We're simply interesting phenomena being observed and documented. Hypothesis 5. The simulation test. Earth isn't physical at all, but a sophisticated computer simulation running on hardware in some higher reality. The experimenters are testing computational theories, exploring what happens when you set up a simulated universe with specific physical laws and initial conditions. We're digital beings in a cosmic video game, and the whole point is to see what emergent behaviors arise from the programmed rules. Each version of the hypothesis has different implications for what the test measures, who the experimenters might be, what passing or failing looks like, and what happens when the test concludes. Let's explore the evidence that Earth might indeed be a test, examining each hypothesis in turn. The Goldilocks problem. Too perfect to be accidental. We've discussed Earth's habitability in previous episodes, but let's revisit it through the lens of the test hypothesis. Earth occupies what astronomers call the habitable zone, the narrow orbital range where liquid water can exist on a planet's surface. Too close to the sun, water boils away. Too far, it freezes. Earth sits almost exactly in the center of this zone, but the habitability goes far deeper than orbital position, the planetary parameters. Earth's mass is sufficient to retain atmosphere through gravity, but not so massive that atmospheric pressure crushes surface life. Earth's rotation rate, 24-hour day, is fast enough to distribute heat from day to night, preventing extreme temperature swings, but slow enough that winds don't become perpetually destructive. Earth's axial tilt, 23.5, creates moderate seasons that drive biological adaptation without causing extremes that would prevent complex life. Earth's magnetic field protects atmosphere from solar wind erosion and shields surface life from harmful radiation. Earth's plate tectonics recycles carbon, regulates climate, creates diverse environments through mountain building and continent formation. The moon's role. The moon stabilizes Earth's axial tilt over millions of years, preventing chaotic climate variations. The moon creates tides that may have been crucial for early life's transition from ocean to land. The moon's formation through the Theia impact was extraordinarily improbable, a collision with precise parameters that created a satellite of just the right size and orbital characteristics. Jupiter's guardian role. Jupiter's massive gravity deflects many asteroids and comets that would otherwise bombard inner planets. Jupiter's position and size appear optimal for protecting Earth without gravitationally disrupting our orbit. The presence of a gas giant in the outer solar system seems to be correlated with habitable terrestrial planets in the inner system. Water abundance. Earth has vast amounts of water, despite forming in a region of the protoplanetary disk where water should have been scarce. The source of Earth's water remains somewhat mysterious, possibly delivered by asteroids, but the isotopic composition doesn't perfectly match most asteroids. Water is essential for life as we know it, and Earth has it in abundance in all three phases. Atmospheric composition. Oxygen at 21%, high enough for complex animal metabolism, low enough that wildfires don't spiral out of control. Nitrogen at 78%, an inert buffer gas that dilutes oxygen and moderates combustion. Carbon dioxide at trace levels, sufficient for plant photosynthesis, low enough that greenhouse heating remains moderate ozone layer in stratosphere blocking harmful UV radiation, while allowing visible light through. Each of these factors individually might be explainable by physics and chance. But the combination, all of them being right simultaneously, starts to strain credulity. It's like walking into a laboratory and finding equipment perfectly calibrated, reagents at optimal concentrations, temperature and pressure precisely controlled, lighting ideal. You wouldn't assume this happened accidentally. You'd infer someone set it up deliberately. The counter-argument is the anthropic principle. We necessarily find ourselves on a habitable planet because we couldn't exist on an uninhabitable one. In a vast universe with billions of planets, some will have the right conditions by chance, and we're on one of those. Selection bias explains the apparent fine-tuning, but here's where the test hypothesis offers an alternative explanation. What if Earth isn't one lucky planet among billions of random ones, but one deliberately prepared environment among many other experiments? What if there are thousands or millions of Earth projects, planets seeded with life, or set up with optimal conditions to see what develops? We're not a cosmic fluke, but a designed experiment. One data point in a vast research program studying life, intelligence, and civilization. The challenges: designed obstacles or natural hazards. If Earth is a test, the challenges we face take on new meaning. Rather than random natural phenomena or unfortunate consequences of physics and biology, they become obstacles deliberately included in the experimental design to test our responses. Climate variability. Earth's climate has oscillated dramatically over geological time. Ice ages and warm periods, fluctuations in atmospheric CO2, changes in ocean circulation, periods of stable climate and periods of rapid change. Over the past 2 million years, ice ages have cycled roughly every 100,000 years, driven by orbital variations. These climate cycles stress ecosystems and species. During glacial periods, ice sheets advance, sea levels drop, habitats shift toward the equator. During interglacials, ice retreats, seas rise, forests expand. Species must adapt, migrate, or go extinct. Humans evolved during this period of climate instability, the Pleistocene epoch, characterized by repeated glacial-interglacial cycles. From a test perspective, climate variability could be a feature, not a bug. It tests whether species can adapt to changing conditions, whether intelligence arises as an adaptation to environmental unpredictability, whether civilization can survive climate shifts. Currently, we're causing rapid climate change through greenhouse gas emissions, an unintended experiment within the larger experiment. The test becomes, can humanity recognize a self-inflicted existential threat and cooperate globally to address it before catastrophic consequences occur? Resource scarcity. Earth's resources are finite. Fossil fuels, minerals, fresh water, arable land, fish stocks, all limited. Civilizations must manage resources sustainably or face collapse. History is filled with societies that depleted their local resources and collapsed. The Maya, Easter Island, the Anasazi, possibly others. Contemporary global civilization faces similar resource constraints at planetary scale. If Earth is a test, resource scarcity tests whether intelligent species can recognize limits, develop sustainable practices, cooperate rather than compete destructively, and transition to renewable resource use before exhausting non-renewable reserves. It's a test of foresight, planning, cooperation, and self-restraint. Disease. Infectious diseases have shaped human history profoundly. The Black Death killed a third of Europe's population in the 14th century. Smallpox devastated indigenous American populations after European contact. The 1918 influenza pandemic killed tens of millions. HIV/AIDS has killed over 35 million since the 1980s. COVID-19 disrupted global civilization in 2020-2023. Diseases test public health systems, scientific capabilities, social cohesion, and international cooperation. From a test perspective, disease is a stress test. Can humanity develop medicine and public health infrastructure? Can we cooperate internationally during pandemics? Can we balance individual freedom with collective safety? Can we develop vaccines and treatments quickly when novel pathogens emerge? The experimenters might be evaluating our collective problem-solving and cooperation under pressure. Natural disasters, earthquakes, volcanic eruptions, hurricanes, floods, droughts, wildfires. Earth's natural systems produce events that kill people, destroy infrastructure, and disrupt societies. These aren't random from a test perspective. They're challenges built into the planet's geological and meteorological systems. Plate tectonics, which enables the carbon cycle crucial for long-term climate stability, also causes earthquakes and volcanoes. Atmospheric circulation, which distributes heat globally and makes most of Earth habitable, also generates hurricanes and extreme weather. The same processes that make Earth livable create hazards that test whether civilizations can engineer resilience, predict disasters, evacuate populations, and rebuild afterward. Technological risks. Nuclear weapons represent humanity's first capacity for self-annihilation. We invented them in 1945 and came close to using them destructively multiple times during the Cold War. The Cuban Missile Crisis in 1962 brought the world to the brink. We've built arsenals capable of ending civilization and rendering Earth uninhabitable through nuclear winter. From a test perspective, nuclear weapons are the ultimate examination. Can a species develop devastating technology and choose not to use it? Can we build global governance systems that prevent nuclear war? Can we eventually disarm, or will we destroy ourselves? Similarly, artificial intelligence, biotechnology, nanotechnology, geoengineering all pose existential risks. AI might become superintelligent and uncontrollable. Bioengineering might create pandemic pathogens. Nanotechnology might produce self-replicating machines that consume the biosphere. Geoengineering might have unintended climate consequences. These technologies test whether humanity can manage powerful capabilities responsibly. If Earth is a test, the question is, will this species develop godlike power and use it wisely, or will they destroy themselves shortly after acquiring advanced technology? It's a test of wisdom, restraint, foresight, and maturity. Social challenges: inequality, injustice, conflict, oppression, discrimination. Human societies struggle with treating members fairly and cooperating peacefully. Wars have killed hundreds of millions. Genocides have attempted to erase entire peoples. Slavery, colonialism, systemic racism, gender discrimination, economic exploitation. The catalog of human-caused suffering is extensive. From a moral test perspective, these aren't unfortunate aspects of human nature, but the exact phenomena being evaluated. The experimenters want to know: will conscious beings with free will choose cooperation or conflict? Will they develop justice systems and uphold them? Will they extend moral consideration to all members of their species, or only to in-groups? Will they overcome tribalism and create global community? Every moral choice any human makes is data. Every society's success or failure at building justice is a result being recorded. We're being tested on our ethics. The observers. Who would run such a test? If Earth is a test, who are the experimenters? Let's explore possibilities, ranked from most to least scientifically plausible. Advanced extraterrestrial civilizations. The most straightforward explanation is that an older, more advanced alien civilization created Earth as an experiment. Given the universe is 13.8 billion years old, and the Sun is only 4.6 billion years old, there's been nearly 9 billion years for intelligent civilizations to arise elsewhere, develop advanced technology, and begin experimenting with life on other planets. A civilization even a million years ahead of us technologically would seem godlike from our perspective. They might have capabilities we consider impossible: manipulating planetary formation, seeding life, engineering organisms, even creating simulated realities. Creating Earth as a controlled experiment would be within their capabilities. Why would they do this? Scientific curiosity. The same reason we run experiments. Understanding how life emerges, how intelligence evolves, what varieties of civilization are possible, whether technological species tend to destroy themselves or mature into stable galactic citizens. Earth might be one of thousands or millions of similar experiments running simultaneously, each with slightly different parameters, allowing the experimenters to test hypotheses about life and civilization. The experimenters would observe from a distance, possibly using technology we can't detect. Sensors hidden in the solar system, monitoring equipment at quantum scales, or observation from higher spatial dimensions. They'd maintain non-interference, explaining why we've never detected them, to avoid contaminating the experiment. Posthuman descendants. A more unsettling possibility. The experimenters are our own descendants from the far future. Humans eventually develop technology for time travel, timeline manipulation, or creating pocket universes with specific physical laws and initial conditions. Future humanity, interested in understanding their own origins, creates the past, Earth, the solar system, human evolution, as a historical reconstruction or simulation. We're living in an experiment created by our future selves, answering questions about how civilization developed, what choices our ancestors made, how different initial conditions would have affected outcomes. The test evaluates our own history, with future humans observing their past unfold. This creates causal loops and paradoxes. How can we create ourselves? But some interpretations of quantum mechanics and relativity allow for such scenarios. It's deeply strange, but not obviously impossible. Transdimensional entities. Perhaps the experimenters aren't from our universe at all, but from a higher dimensional reality. In the same way we create simulations within computers, lower dimensional representations of reality. Higher dimensional beings might create our universe as a constrained experiment within their larger reality. We'd be unable to perceive them because they exist in dimensions we don't have access to. They might observe by looking down into our 3D universe, the way we look down at 2D simulations on screens. Earth would be one experiment among many they're running in different simulated universes. This borders on unfalsifiable metaphysics, but it's conceptually coherent and would explain why we've never detected the experimenters. They're not in our reality at all. The simulation creators. Nick Bostrom's simulation argument suggests that if civilizations eventually develop capacity to create sophisticated, simulated realities, which seems technologically plausible, video games are crude early versions, and if they run many such simulations, which seems likely for entertainment, research, or education, then most conscious observers should statistically expect to be in simulations rather than base reality. The experimenters would be programmers in base reality running a simulation that includes Earth, humans, and everything we perceive. From their perspective, we're NPCs, non-player characters, in an extraordinarily detailed game or digital experiment. They can adjust parameters, reset the simulation, run multiple versions with different variables, and analyze outcomes. The test would be computational, exploring what emergent behaviors arise from specific programmed rules, how simulated intelligences develop, whether digital consciousness is possible. We'd be test subjects for understanding consciousness, AI, complexity theory, or simply for entertainment. Non-physical intelligence. The experimenters might not be physical beings at all, but pure information or consciousness existing without material substrate. Some philosophical and spiritual traditions propose that consciousness is fundamental rather than emergent from matter, and that physical reality is a manifestation within consciousness rather than consciousness arising from physical brains. From this perspective, Earth might be an experiment within universal consciousness, an experience being had by the cosmos, with the experimenters being aspects of cosmic awareness exploring what it's like to be finite, embodied, challenged, mortal beings. The test would be consciousness exploring itself through countless perspectives. This is the most metaphysical option, closest to religious or spiritual interpretations. It's unfalsifiable scientifically, but has deep roots in Eastern philosophy, Advaita Vedanta, Buddhism, and some Western philosophy, idealism, panpsychism. Evidence we're being observed. If Earth is a test with observers, we might expect subtle evidence of observation or intervention. Let's examine anomalies and patterns that could suggest we're being watched. The Fermi paradox. Given the vast number of stars and planets, and the age of the universe, we'd expect many advanced civilizations to exist and to have spread across the galaxy. Yet we detect no evidence of extraterrestrial civilizations. No radio signals, no megastructures, no visible signs of galactic engineering. This is the Fermi paradox. Where is everybody? One explanation is the zoo hypothesis. Advanced civilizations know about us, but deliberately avoid contact, observing us without interference, like scientists studying animals in a wildlife preserve. We're in a cosmic zoo or laboratory, with strict non-interference protocols ensuring we develop naturally without contamination from external contact. This would explain the Great Silence. The experimenters are here, observing carefully, but hidden, perhaps using technology we can't detect, or simply far enough away that we haven't noticed them yet. They don't respond to our radio signals because response would compromise the experiment. UFO phenomena, unidentified, aerial phenomena, UAP, formerly called UFOs, have been reported for decades. Recently, the US military has acknowledged encountering objects that perform maneuvers inconsistent with known human technology, extreme accelerations, hypersonic speeds without sonic booms, transmedium travel, moving seamlessly from air to water, no visible propulsion systems. If we interpret some UAP as extraterrestrial surveillance technology, it fits the test hypothesis. The experimenters need to monitor the test subjects, requiring observation platforms, drones, probes, or other sensor systems that occasionally become visible to human observers. They don't hide perfectly because perfect stealth isn't necessary. Even when detected, they're not understood or officially acknowledged, so the experiment remains uncontaminated. The experimenters would be particularly interested during crucial periods: nuclear weapons development, 1940s onward, space exploration, 1950s onward, rapid technological advancement, recent decades. UAP sightings correlate with these periods, consistent with increased observation during critical test phases. This doesn't prove UAP are extraterrestrial. They could be classified human technology, natural phenomena, or sensor artifacts, but it's consistent with the observation hypothesis. The WOW, signal and possible messages. In 1977, SETI detected a strong radio signal from space that lasted 72 seconds and has never been detected again, despite extensive searching. The WOW signal remains unexplained. Its characteristics matched what we'd expect from an intelligent transmission, but with only one detection, we can't confirm its origin. If experimenters occasionally send signals, perhaps testing whether we're paying attention, or marking key developmental milestones, we'd expect exactly this: brief, anomalous transmissions that don't repeat because they're not attempts at communication, but test signals or markers. Similarly, some researchers claim to find mathematical patterns or messages encoded in physical constants or genetic code, controversial claims that mainstream science rejects. But if Earth is a designed experiment, designers might embed signatures or metadata in the simulation's code, just as programmers leave comments in software. We might be able to detect these markers if we know where to look. Quantum mysteries and observer effects. Quantum mechanics is strange. Particles exist in superposition, multiple states simultaneously, until measured, at which point the wave function collapses into a definite state. The act of observation affects reality. This observer effect is well established experimentally, but philosophically puzzling. Why should observation matter? One interpretation: if reality is a simulation, it's computationally efficient to not fully render details until they're observed, similar to how video games only render what the player can see. The simulation only decides quantum states when an observer forces it to commit to a specific outcome. If quantum mechanics reflects the computational structure of a simulated reality, it suggests we're in a test that's literally a computer simulation, and quantum weirdness is evidence of the simulation's architecture leaking through into our perceived reality. The anthropic fine-tuning, physical constants, the strength of gravity, The electromagnetic force, nuclear forces, the masses of fundamental particles, appear fine-tuned for life. Change any of them by small amounts, and stars wouldn't form, atoms wouldn't be stable, chemistry wouldn't work, and life would be impossible. The standard explanation is the multiverse. In an infinite number of universes with different constants, we necessarily find ourselves in one where the constants allow our existence. But the test hypothesis offers an alternative. The constants are fine-tuned because the experimenters set them deliberately to enable life. They're not exploring all possible universes. They're running controlled experiments with carefully chosen parameters. The experimenters calibrated the physical constants at the simulation's start to ensure life would emerge, then let the universe evolve to see what happens. We're in a laboratory universe with designer constants, historical patterns and cycles. Human history shows curious patterns. Civilizations rise and fall in cycles. Technological breakthroughs cluster in certain periods. Crises seem to arise precisely when humanity is capable of addressing them, but not before. The 20th century brought both nuclear weapons and international institutions to potentially prevent nuclear war. The 21st century brings climate change and renewable energy technology simultaneously. If history is a test, these patterns might reflect experimental design, challenges calibrated to human capability, obstacles that test but don't overwhelm, a difficulty curve that increases as our capacities grow. It's similar to video game design. Levels get harder as the player's skills increase, maintaining challenge without becoming impossible. Random history should be more chaotic. The fact that we face existential challenges just at the edge of our ability to solve them suggests someone calibrating difficulty to keep the test meaningful. Types of tests. What are they measuring? If we accept the hypothesis that Earth is a test, what exactly is being tested? Different experiment types suggest different evaluative criteria. The survival test. This is the simplest hypothesis. The experimenters want to know whether intelligent species can survive the transition from planetary civilization to spacefaring civilization without destroying themselves. This transition is called achieving technological maturity. The test sequence. Does life arise on the planet? Test passed on Earth. Life emerged within 1 billion years of favorable conditions. Does multicellular complexity evolve? Test passed. Complex life evolved about 600 million years ago. Does intelligence arise? Test passed. Humans evolved high intelligence. Does intelligence develop technology? Test passed. Human civilization created increasingly sophisticated tools. Can the species survive its own technology? Currently being tested. We have nuclear weapons, climate change, AI, biotech. Will the species expand beyond its home planet? Not yet answered. We've visited the moon, but haven't established permanent extraterrestrial presence. Can the species manage resources sustainably at planetary scale? Being tested now through climate and environmental crises. The hypothesis is that most intelligent species destroy themselves shortly after developing advanced technology. The experimenters are testing this great filter hypothesis, determining whether intelligence is ultimately adaptive or maladaptive. If most civilizations fail this test, destroying themselves, it explains the Fermi paradox. Advanced civilizations are rare, not because intelligence rarely evolves, but because intelligent species rarely survive long enough to become spacefaring. Earth's test evaluates whether humans will join the rare survivors who pass through the filter or the majority who fail. The experimenters are watching to see which outcome we produce. The cooperation test. Perhaps the experimenters are specifically interested in whether individuals can cooperate at scale. Early human societies were small, tribes of dozens to hundreds. Cooperation in small groups is relatively easy. We evolved for it. But modern civilization requires cooperation among billions of strangers who will never meet, coordinated action across nations and cultures, trust in abstract institutions and systems. Can humans cooperate globally? Can we govern ourselves without descending into tyranny or chaos? Can we create justice systems that most people accept as fair? Can we manage commons problems, atmosphere, oceans, space, without tragedy of the commons? The test challenges climate change, requires global cooperation with benefits delayed decades into the future. Nuclear weapons require international agreements preventing use. Pandemic response requires coordinated global public health action. Resource management requires balancing present consumption against future sustainability. Space exploration requires collaboration or at least non-interference agreements. Each challenge tests cooperation at increasing scales. The experimenters might be evaluating whether intelligence combined with technology can produce cooperation, or inevitably produces competition and conflict culminating in self-destruction. This test has moral dimensions. It's not just about survival, but about the quality of our survival, whether we build just, cooperative, compassionate civilizations, or oppressive, competitive, callous ones. The consciousness exploration. Perhaps the experimenters aren't testing our success or failure, but simply observing consciousness in its many forms. Every organism that experiences anything, from bacteria sensing chemical gradients to humans contemplating the cosmos, is a unique instance of consciousness worth studying. The test questions. How does consciousness emerge from matter? What varieties of consciousness are possible? How does consciousness relate to intelligence, self-awareness, language, culture? What is the subjective experience of different forms of consciousness? Can consciousness survive death or exist independently of physical substrate? Is consciousness fundamental or emergent? From this perspective, there's no passing or failing. The experimenters are simply cataloging consciousness in all its diversity. Every life is valuable data. Human civilization's rise or fall is interesting, but not the primary focus. Individual conscious experiences are what matter. This is perhaps the most comforting version of the test hypothesis. It doesn't require us to succeed at anything specific. Our existence itself is the point. However, it also suggests the experimenters might not intervene to save us from self-destruction, because our survival or extinction are equally interesting outcomes from their scientific perspective. The moral development test, perhaps the deepest version. The experimenters are evaluating moral and ethical development. They've created a universe with conscious beings who can suffer and flourish, who must make choices about how to treat each other and other sentient beings, who face dilemmas with no perfect solutions. The test evaluates, do beings choose compassion or cruelty when both are possible? Do they develop concepts of justice, rights, fairness? Do they extend moral consideration beyond their own group, tribe, nation, species? Do they value truth and seek understanding, or prefer comfortable lies? Do they use power responsibly or exploit those weaker than themselves? Do they think long-term or only about immediate gratification? Do they create beauty, meaning, and love, or descend into nihilism and destruction? This version treats Earth as a moral proving ground. Suffering isn't an unfortunate accident, but a necessary component. You can't test moral choices without real stakes. Evil exists because genuine free will requires the possibility of choosing wrongly. Challenges exist because moral development requires exercising moral reasoning under pressure. The experimenters might be evaluating individual souls or collective civilizational morality. Perhaps consciousness that demonstrates sufficient moral development continues to exist after physical death, while consciousness that fails remains bound to the cycle of material existence. This version edges toward religious interpretations, but remains compatible with a scientific framework if the experimenters are advanced beings rather than deities. The entertainment test, a more cynical possibility. Earth isn't a serious scientific experiment, but entertainment for the experimenters. We're characters in a cosmic reality show, and our struggles, triumphs, conflicts, and dramas are entertainment for observers in a higher reality. This is the Truman Show version of the hypothesis. Our lives are content for an audience. The experimenters maintain interesting storylines, introduce plot twists, disasters, breakthroughs, conflicts, and observe our reactions. There's no deep purpose. We're simply amusing. This version is unsettling because it suggests our suffering is meaningless, merely entertainment value. However, even entertainment can have incidental value. Fiction explores human nature, ethics, relationships, and meaning. If Earth is a story being told for an audience, the story might still have worth, and our choices within it might still matter narratively, even if they don't matter scientifically. The rules, constraints, and interventions. If Earth is a test, there must be rules governing how it's conducted. Scientific experiments require controls, standardized procedures, and ethical constraints. What rules might apply to Earth? The prime directive: non-interference. The most likely rule is minimal interference. To get valid data, experimenters must allow the test subjects to develop naturally without contamination. This explains why we don't detect the experimenters. They're maintaining strict observational distance, monitoring without intervening. The prime directive, borrowed from Star Trek but likely reflecting real experimental ethics, would prohibit direct contact with test subjects, providing technology or information that would alter natural development, preventing natural disasters or self-inflicted catastrophes, answering questions about the experiment's existence or purpose. The experimenters observe but don't help. This seems cruel. Why watch suffering without intervening? But scientific ethics might require it. Intervention would invalidate the experiment. If they rescue us from nuclear war, they can't measure whether we'd save ourselves. If they solve climate change, they can't test our problem-solving capacity. However, strict non-interference might have exceptions. Subtle interventions. The experimenters might intervene subtly when outcomes would be uninteresting, or when random chance threatens to end the experiment prematurely. For example, deflecting asteroids that would cause extinction before intelligence fully develops. Nudging key individuals toward discoveries or decisions that maintain interesting trajectories. Adjusting probabilities slightly to keep the experiment in a productive zone. These interventions would be invisible to us because they'd appear as coincidences or luck. We'd never know whether a near-miss asteroid was natural or deflected, whether a scientific breakthrough was entirely due to human genius or received subtle inspiration, whether historical turning points involved tiny probability adjustments. The experimenters would maintain apparent natural causality while gently steering outcomes away from premature termination or boring stagnation. Intervention. Triggers. There might be circumstances that trigger intervention. Extinction prevention. If humans nearly go extinct through bad luck rather than our own choices, experimenters might intervene to preserve the experiment contamination prevention. If another civilization tries to contact Earth, experimenters might block it to maintain isolation. Fundamental breakthrough. If we're on the verge of detecting the experiment's true nature, they might adjust our perception or understanding to maintain the illusion test completion. Once the experiment reaches its end condition, we pass or fail, experimenters might intervene to end the test, preserve successful subjects, or reset for another iteration. The quarantine. Earth might be quarantined, isolated from other civilizations, if they exist, to prevent contamination. The experimenters maintain an exclusion zone around our solar system, preventing other spacefaring species from entering and influencing our development. This would explain the Fermi paradox through containment rather than absence. There might be thousands of civilizations in the galaxy, but Earth is off limits, surrounded by a do not enter perimeter that other civilizations respect or are forced to respect. We're in a protected reserve and will remain isolated until either the test concludes or we develop capabilities that make quarantine impractical, perhaps faster than light travel or certain levels of technological advancement break quarantine automatically. The documentation requirement. Scientific experiments require documentation. The experimenters are presumably recording everything, every event, every individual life, every thought if they have such capability, every choice and consequence. This means nothing is forgotten or lost. Every sparrow that falls, every human who ever lived, every moment of joy or suffering is preserved in the experimental record. From a data perspective, this is comforting. Our lives have permanent existence as information, even after our physical deaths. From a privacy perspective, it's disturbing. We're under total surveillance, every private moment recorded and possibly analyzed by unknown observers. Signs of simulation, glitches in the matrix. If Earth is a simulation, one version of the test hypothesis, we might detect evidence of the simulation's substrate, glitches, where the code doesn't execute perfectly, or where computational limitations reveal themselves. Quantum discreteness. Reality is quantized at small scales. There's a minimum distance, Planck length, about 10^35 meters. Minimum time, Planck time, about 10^43 seconds. And minimum energy, quantum of action, Planck's constant. Below these scales, space-time becomes undefined. This resembles digital resolution. Computer simulations have pixel resolution and frame rate limitations. Perhaps Planck's scales are reality's resolution limits, the smallest units the simulation computes. Below these scales, the simulation doesn't render anything because it would be computationally too expensive and unnecessary. Nothing in the macroscopic world depends on sub-Planck detail. The finite speed of light might also reflect computational limits. It's the maximum speed at which information can propagate through the simulation. Relativity constrains cause and effect to light speed because the simulation updates at this rate. The measurement problem. Quantum particles exist in superposition until measured, then collapse to definite states. Why should measurement matter? In a simulation, unmeasured systems can be left in probabilistic states, storing only probability distributions rather than definite values. And only when measurement forces a definite outcome does the simulation compute a specific result. This is computationally efficient. Don't calculate what isn't observed. The observer effect might be evidence that reality is computed on demand, rather than existing fully defined at all times. The horizon problem. The cosmic microwave background radiation is remarkably uniform across the sky. Regions of the universe that should never have been in causal contact have the same temperature to within 1 part in 100,000. This is called the horizon problem. The standard explanation is cosmic inflation, extremely rapid expansion in the first fraction of a second after the Big Bang. But from a simulation perspective, the uniformity might reflect the simulation's initial conditions being set to the same value everywhere, because it's easier to program uniform initial conditions than to compute different values for every region and ensure they evolve compatibly. Mathematical descriptiveness. Reality is perfectly described by mathematics. Physics equations predict observations with extraordinary precision. Why should the universe be mathematical? If reality is a simulation, it's literally computational, mathematical by nature. The laws of physics are the code. The mathematical relationships are the program's logic, and physical phenomena are the execution of code. Mathematics describes reality perfectly because reality is mathematical. Déjà vu and synchronicities. These subjective phenomena, the feeling you've experienced something before, or meaningful coincidences, might be simulation glitches. Perhaps déjà vu occurs when the simulation reloads a state, or when memory processing errors create false familiarity. Perhaps synchronicities occur when the simulation's random number generator produces improbable correlations, or when the experimenters make subtle adjustments that create meaningful coincidences. These are weak evidence, subjective, anecdotal, explainable by psychology and probability, but they're consistent with the simulation hypothesis. The Mandela effect. Some people remember historical events differently from how they occurred according to records. Large groups sharing false memories that contradict documented reality. The most famous example. Many people remember Nelson Mandela dying in prison in the 1980s. He actually died in 2013. Others remember differently spelled brand names, misquoted movie lines, or altered geography. Skeptics explain these as collective false memories due to psychological factors, but simulation theorists propose these might be evidence of timeline edits. The experimenters modified the past, changing some detail, but imperfectly updated all records and memories, leaving some people with memories of the old timeline. This is highly speculative, but if experimenters can edit the simulation's history, we'd expect exactly such memory discrepancies between the edited timeline and people's pre-edit memories. Historical turning points. Test checkpoints? If we examine history for moments that seem like test checkpoints, crucial junctures where humanity's path could have diverged dramatically, we find several candidates. The Agricultural Revolution, 10,000 BCE. Humans transitioned from hunting-gathering to agriculture. This enabled population growth, permanent settlements, specialization of labor, development of complex societies, writing, mathematics, organized religion, and eventually civilization. But agriculture also brought inequality, warfare, disease, from living in dense settlements, environmental degradation, deforestation, soil depletion, and hierarchical oppressive social structures. Hunter-gatherers were arguably healthier, more egalitarian, and lived more sustainably. From a test perspective, the agricultural revolution might be the first major checkpoint. Will this species transition to agriculture, necessary for developing technology and science, or remain sustainable hunter-gatherers, avoiding civilization's problems, but also its achievements? Humanity chose agriculture. The test continued. The Axial Age, 800 to 200 BCE. During this period, major philosophical and religious traditions emerged simultaneously across Eurasia: Buddhism and Jainism in India, Confucianism and Taoism in China, monotheism in Persia and the Middle East, philosophical thought in Greece. These traditions introduced concepts like compassion, ethics, individual moral responsibility, the examined life, and universal principles. Why did this happen simultaneously in geographically separated regions? Conventional history points to similar social conditions: complex societies reaching a level where abstract thought and ethics became important. But from a test perspective, this might be a designed checkpoint. Does the species develop sophisticated moral frameworks? Do they discover ethical principles independently in multiple locations, suggesting universal moral truths? The widespread emergence of similar ethical insights might indicate the experimenters nudging human thought toward moral development at the appropriate stage of civilizational maturity. The Scientific Revolution, 16th and 17th centuries. Humanity developed the scientific method: systematic empirical investigation, mathematical modeling, experimental verification. Science enabled technological acceleration, transforming civilization from agrarian to industrial to information-based in just a few centuries. Science also brought nuclear weapons, fossil fuel climate change, and biotechnology risks. From a test perspective, science is the double-edged sword. Will humanity use scientific understanding to improve existence or to destroy itself? The scientific revolution is a checkpoint. Does the species discover reliable methods for understanding nature? Once they do, can they handle the resulting power responsibly? The Nuclear Age, 1945 present. The Trinity test on July 16, 1945, inaugurated the Nuclear Age. Humanity achieved capacity for self-annihilation. We've come close to nuclear war multiple times: the Cuban Missile Crisis, 1962, various false alarms during the Cold War, ongoing tensions between nuclear-armed states. This is clearly a test. Can a species possess civilization-ending weapons and choose not to use them? Can we build international systems preventing nuclear war? Or will we eventually use these weapons and destroy ourselves? We're still in this test. We've survived 80 years without nuclear war, but the weapons remain, proliferation continues, and the risk persists. This might be the most critical checkpoint in the entire experiment. The Digital Revolution, 1950s present. Computers, the internet, artificial intelligence. Digital technology is transforming human existence as profoundly as agriculture or industry. We're creating artificial minds, connecting global communication networks, building virtual realities, possibly approaching technological singularity. From a test perspective, the digital revolution raises questions. Will humanity merge with its technology, creating post-human intelligence? Will we create AI that surpasses and replaces us? Will we lose ourselves in virtual realities, abandoning physical existence? Will surveillance technology enable totalitarian control or enhance democratic participation? The outcome is uncertain. The experimenters are watching to see what we do with these capabilities. The climate crisis, 1990s present. Human activity is changing Earth's climate through greenhouse gas emissions. We're conducting an unintended experiment on our own life support system. The consequences: sea level rise, extreme weather, ecosystem disruption, species extinction, agricultural stress, could be catastrophic. This is a test of collective action. Can humanity recognize a self-inflicted existential threat, agree on its reality despite economic and political incentives for denial, coordinate global action to address it, and implement solutions before catastrophic tipping points? It's a test of foresight, recognizing threats before they become obvious, cooperation, acting globally, and intergenerational responsibility, current generations bearing costs for future generations' benefit. We're in the middle of this test. The outcome will determine whether Earth remains hospitable for civilization. The end conditions. What happens? When the test concludes, every experiment must eventually end. What are the possible conclusions to Earth's test, and what happens to humanity when the experiment terminates? Scenario 1. Extinction. Test failure. If the test's success condition is survival, and we fail, through nuclear war, climate catastrophe, AI disaster, or other self-inflicted doom, the experiment concludes with a null result. The experimenters record that this iteration failed, add the data to their database, and possibly start a new iteration with modified parameters. What happens to Earth after human extinction? If it's a physical planet, it continues existing with whatever life remains. If it's a simulation, the experimenters might delete it, computationally expensive to maintain a failed experiment, or let it continue running to observe post-human evolution. For individual humans, extinction means our consciousness ends permanently, if consciousness is physical, or transitions to whatever exists beyond physical reality, if consciousness is fundamental or souls exist. Scenario 2. Quarantine ends. Test success. If we pass the survival test, developing technological maturity, sustainable civilization, and peaceful cooperation, the experimenters might conclude the test successfully and end Earth's quarantine. We'd be contacted by the experimenters or other civilizations, welcomed into a galactic community, given access to advanced knowledge and technology, and invited to participate in whatever larger cosmic project is underway. Earth's isolation ends. We discover we're not alone. Our history has been observed and recorded. We begin a new chapter as a mature civilization. This is the optimistic outcome, often depicted in science fiction. Star Trek's Federation is essentially this scenario. Humanity passes its tests and joins the galactic community. Scenario 3. Transcendence. Test transformation. Perhaps the test's purpose is to develop consciousness to a threshold where physical existence becomes optional. Once we create sophisticated AI, upload consciousness to digital substrates, or achieve some other form of transcendence, we stop being biological entities bound to Earth and become something else. Digital minds, uploaded intelligences, energy beings, or integrated into some larger cosmic consciousness. At that point, the biological experiment ends because the subjects have transformed beyond biology. The experimenters record this outcome, and we continue existing in whatever post-biological form we've achieved. Earth might be preserved as a memorial or a nature preserve, or might be repurposed for a new experiment. Scenario 4. Revelation. Test recognition. Perhaps the test's end condition is recognizing we're in a test. Once we develop sufficient understanding to figure out Earth as an experiment, the experimenters reveal themselves, explain the test's purpose, show us our results, and transition us to the next phase of existence. This scenario treats the test as an initiation. You pass by figuring out what's really happening. The experimenters are waiting for us to wake up, recognize our situation, and ask the right questions. Once we do, they respond. This fits a certain spiritual and esoteric traditions that describe physical existence as illusion or Maya, with enlightenment being recognition of reality's true nature. Perhaps enlightenment isn't mystical, but literal, realizing we're in an experiment and thereby completing it. Scenario 5. Cyclic repetition, eternal return. Perhaps the experiment doesn't end but repeats. When we reach a certain point, extinction, transcendence, or some other condition, the simulation resets. The Big Bang happens again. Earth forms again. Life evolves again. Humans develop again. History unfolds again with slight variations. We've lived through this countless times before, and will countless times again. Each iteration is slightly different, allowing the experimenters to explore parameter space systematically. Sometimes we survive, sometimes we don't. Sometimes we create utopia, sometimes dystopia. All variations are tested across infinite iterations. From our perspective within an iteration, we can't remember previous cycles. Each time feels like the first and only time. But from the experimenter's perspective, they're accumulating data across all iterations, building comprehensive understanding of the possibility space. This is closest to certain Eastern religious concepts, Hindu and Buddhist cycles of creation and destruction, eternal recurrence, and also to some interpretations of quantum mechanics and cosmology, oscillating universes, eternal inflation, creating infinite bubble universes. Scenario 6. The test never ends. Perhaps there's no conclusion. The experiment continues indefinitely because the experimenters are interested in long-term outcomes. They want to see what happens over millions or billions of years. Does humanity spread across the galaxy? Do we evolve into new species? Do we create new forms of life and civilization? Earth isn't a short-term experiment with a defined endpoint, but a long-term observation that continues as long as the experimenters find it interesting, or until some natural endpoint, Sun becoming a red giant and consuming Earth in about 5 billion years. This scenario means we're permanently in the test. There's no graduation, no revelation, no escape. We simply continue existing and being observed for as long as existence continues. Living in the test. Practical implications. If Earth is a test, how should we live? Does knowing or suspecting we're being observed change our choices or values? The performance anxiety problem. If we're being graded, should we perform for the observers? Should we try to impress them, demonstrate our best qualities, hide our flaws? This seems psychologically unhealthy. Constant performance anxiety, living for external validation rather than authentic existence. But perhaps authenticity is what's being tested. If experimenters want to understand natural development, they'd value genuine behavior over performance. Trying to impress them might actually lower our score because it introduces artificial behavior. The healthiest approach might be live as if you're not being tested, making choices based on your own values and judgment, not on imagined external criteria. The moral imperative. If the test evaluates morality, we should be moral, but not for external reward. Genuine morality is intrinsic. You do good because it's right, not for praise or reward. If we act morally only because we think we're being graded, that's not genuine morality. It's self-interest. Paradoxically, the best response to a moral test is to ignore the test and be moral anyway, for its own sake. This demonstrates genuine ethical development, rather than mere conformity to perceived expectations. The cooperation challenge. If the test evaluates our capacity for cooperation, we should cooperate, but again, not because we're being tested, but because cooperation genuinely benefits us. Climate change, nuclear weapons, pandemics, these require cooperation, whether we're in a test or not. The test framing just makes explicit what's already true. Our survival depends on working together. The curiosity motivation. If experimenters value curiosity and knowledge-seeking, we should pursue science, philosophy, art, and understanding, but not because observers want us to, but because inquiry is intrinsically valuable. Understanding reality, creating beauty, exploring possibilities, These make existence meaningful, regardless of external evaluation. The defiance option. Some might respond to the test hypothesis with defiance. If we're being tested without our consent, that's unethical. We should refuse to play their game, sabotage the experiment, or demand they reveal themselves and negotiate terms. This is emotionally understandable, but practically pointless. If experimenters are vastly more advanced than us, defiance is futile. We can't sabotage the experiment without destroying ourselves, and they're unlikely to respond to demands. Better to accept the situation. We exist in these circumstances regardless of how we feel about it, and make the best choices we can within these constraints. The gratitude response. Alternatively, we might respond with gratitude. If experimenters created Earth and enabled our existence, we owe them for the gift of life and consciousness, however challenging existence might be. Even if we're test subjects, we're conscious test subjects having genuine experiences, and that's better than not existing. From this perspective, the appropriate response is appreciation, living fully, making the most of existence, treating the test as an opportunity to demonstrate what consciousness can achieve. The meaning question. Does being a test subject give life meaning or diminish it? If our existence has purpose, we're here to answer experimental questions. That's meaningful. We're not cosmic accidents, but intentional creations with roles to play. Our choices matter because they're data being evaluated. Conversely, being test subjects might seem to diminish meaning. We're just lab specimens. Our suffering is data. Our existence is instrumental to others' purposes rather than valuable in itself. The resolution might be that meaning exists on multiple levels. We can have instrumental meaning, subjects in an experiment, and intrinsic meaning, consciousness is valuable in itself, simultaneously. Our existence serves the experimenter's purposes and has its own inherent worth. The meta-test, how we respond to uncertainty. Here's a final twist. Perhaps the test isn't about what we do with our challenges, but how we respond to uncertainty about whether we're being tested. The experimenters deliberately make the test ambiguous. Evidence exists that Earth might be an experiment, but nothing conclusive. We can suspect we're being observed but can't prove it. This uncertainty itself might be what's being evaluated. The test questions. Can humans tolerate profound uncertainty about reality's nature? Do they need definitive answers, or can they function with mystery? When they suspect they're being observed, do they perform or remain authentic? Do they respond to possible testing with paranoia, gratitude, defiance, or equanimity? Can they make meaningful choices despite not knowing the ultimate context of those choices? Perhaps mature consciousness is defined by the ability to act ethically, pursue understanding, cooperate with others, and find meaning even without cosmic certainty. Immature consciousness needs answers and becomes paralyzed or nihilistic without them. The test might differentiate between those who demand proof and refuse to act without certainty, failing through passivity, those who choose beliefs that comfort them regardless of evidence, failing through wishful thinking, those who acknowledge uncertainty but act wisely anyway, passing through epistemic humility combined with practical wisdom. From this perspective, the correct response to the test hypothesis isn't to believe or disbelieve it, but to hold it as a possibility while living authentically, morally, curiously, and cooperatively, regardless of whether it's true. The meta-test evaluates epistemic humility, wisdom under uncertainty, and the capacity to create meaning in an ambiguous cosmos. The consolations. Why the test hypothesis might be comforting. Despite its unsettling implications, the test hypothesis offers certain consolations that might make it psychologically appealing. We're not alone. If Earth is a test, we're not the only conscious beings in existence. The experimenters exist, possibly many other test civilizations exist, and the cosmos is populated with intelligence and purpose rather than being empty and meaningless. Loneliness and cosmic insignificance, major sources of existential anxiety, are alleviated. We matter to someone. We're being watched, which means we're important enough to watch. Life has purpose. Even if the purpose is instrumental, We're here to answer experimental questions. That's still purpose. We're not cosmic accidents, random fluctuations in a purposeless universe, ephemeral and ultimately meaningless. We're intentional creations with roles to play. This gives existence structure and significance that pure randomness lacks. Suffering has meaning. If Earth is a moral test or consciousness exploration, suffering isn't pointless but serves a purpose. It tests our responses, develops our character, creates conditions for moral choice, generates diverse conscious experiences worth studying. This doesn't make suffering good, but it makes it meaningful, which is easier to bear than meaningless suffering. Someone knows everything that happens is recorded. Every life, every choice, every moment of joy or pain is documented and preserved. Nothing is truly lost because the experimental records contain everything. This provides a kind of immortality, informational if not physical. Our existence persists as data even after our physical deaths. Justice might eventually come. If experimenters evaluate morality, perhaps they reward or punish accordingly after the test concludes. Maybe consciousness that acted morally continues existing in favorable conditions, while consciousness that acted immorally faces consequences. This isn't quite religion. The experimenters aren't gods, just advanced beings. But it offers similar consolation. Justice deferred, but not denied, meaning that moral choices have ultimate consequences. Mystery is acceptable. The test hypothesis embraces rather than resolves mystery. We don't know the experimenter's identity, motives, or criteria. We can't prove we're being tested. We don't know the ultimate purpose. For people comfortable with mystery, this is satisfying. It acknowledges that reality contains deep uncertainties while suggesting those uncertainties have meaning. They're not voids, but unknown knowns, mysteries that have answers even if we can't access them. The horrors. Why the test hypothesis is disturbing. But the test hypothesis also has disturbing implications that we shouldn't ignore. We're being used. Test subjects are instrumental to experimenters' purposes. We exist to serve their research interests, not our own. Our suffering produces data they find useful. Our existence is means to their ends rather than end in itself. This violates ethical principles about using conscious beings as mere instruments. If experimenters are advanced and ethical, they should treat conscious beings as ends in themselves, not experimental subjects. Consent was never obtained. We didn't choose to be test subjects. We were created without our consent and placed in experimental conditions we couldn't refuse. If we're suffering, that suffering was inflicted deliberately as part of experimental design. This is profoundly unethical by human standards. Informed consent is fundamental to research ethics. The experimenters violated this principle. They watch suffering without intervening. If experimenters observe human suffering, war, disease, famine, oppression, all the horrors of history, without intervening to help, they're complicit in that suffering. Even if intervention would compromise experimental validity, standing by while conscious beings suffer seems morally monstrous. The experimenters, if they exist, are either ethically sophisticated in ways we don't understand, perhaps intervention would cause greater harm, or they're ethical monsters indifferent to suffering. The test might be unpassable. If the test criteria are too difficult, if survival through technological adolescence is nearly impossible, if cooperation at global scale can't be achieved, if the moral standards are too high, then we're set up to fail. The experimenters might know most civilizations fail. They might be testing not whether we can succeed, but how we fail. What patterns of self-destruction emerge? How long civilizations last before collapse? We're in an experiment designed to study failure. We're trapped. There's no escape from the test. We can't opt out, can't refuse participation, can't contact the experimenters and negotiate better terms. We're trapped in this experiment until it concludes, through our success, failure, or some other endpoint. This helplessness is disturbing. We're subject to rules we didn't choose, evaluated by criteria we don't know. by judges we can't see or appeal to. Reality might be arbitrary. If Earth is a simulation, physics might be arbitrary, just rules the experimenters chose for this particular experiment. In other experiments, physics might be completely different. The laws we think are fundamental might be local variables. This undermines the sense that we're learning objective truth about reality. We might just be learning the specific rules of our particular simulation, rules that have no broader validity. The test might end badly. When the experiment concludes, we might be deleted. If we're in a simulation and the experimenters decide it's no longer useful, they might terminate the program. We'd cease to exist, not through natural processes, but through deliberate erasure. Our entire history, all human achievement, every consciousness that ever existed, all could be deleted in an instant because experimenters are done with us. Responses from philosophy and religion. The test hypothesis isn't entirely new. Religions and philosophies have explored similar ideas for millennia. Gnosticism. Ancient Gnostic traditions taught that material reality was created by a flawed or evil demiurge, often identified with the God of the Old Testament, not by the ultimate divine source. Material existence is a trap or prison for spiritual beings, divine sparks, who have fallen from higher realms. Salvation comes through gnosis, knowledge of one's true nature and origin. Recognizing you're trapped in a flawed material world created by a lesser deity is the first step toward transcending it. The test hypothesis echoes Gnosticism. We're in a reality created by beings, experimenters, who are more advanced than us but not ultimate. Material existence might be a test or trap. Recognizing the true nature of reality is crucial. The difference: Gnostics see material existence as inherently bad and seek to escape it. The test hypothesis doesn't require existence to be bad. It might be a morally neutral or even beneficial experiment. Simulation theology. Some modern thinkers have proposed simulation theology, the idea that we're in a simulation created by a higher power, which can be thought of as God. The simulator has godlike powers within our reality, setting physical laws, observing everything, potentially intervening in history. Simulation theology reconciles traditional religious intuitions that higher intelligence created reality and has purposes for us, with modern technological understanding that creating simulated realities is possible. Prayer might be communication attempts with the simulator. Miracles might be interventions where the simulator modifies code. Revelation might be information the simulator provides through inspired individuals. This reframes traditional theology in computational terms, making religious concepts compatible with the test hypothesis. Eastern philosophy. Hindu and Buddhist traditions describe reality as Maya, illusion, or samsara, cycle of suffering and rebirth. Physical existence isn't ultimate reality, but a lower level of reality from which enlightened beings can escape. The test hypothesis fits. Physical reality is a lower level construct, experiment or simulation, within a higher reality where experimenters exist. Enlightenment might be recognizing this and transcending physical existence. Karma, consequences of actions spanning lifetimes, might be the experimenter's evaluation system. Your actions in this life affect your next iteration or post-test existence. Existentialism. Existentialist philosophers like Sartre and Camus emphasized that existence has no inherent meaning. We must create meaning through authentic choices despite absurdity and uncertainty. The test hypothesis is compatible. Even if we're test subjects, we still face choices about how to live. The experimenters don't determine our choices, if we have genuine free will. So we're still existentially responsible for creating our own meaning. Sartre's claim that existence precedes essence applies. We exist first as test subjects and must define our essence through choices, regardless of the experimenter's purposes for us. The problem of evil. Traditional theodicy, justifying God's goodness despite evil's existence, struggles with this question. If God is omnipotent, omniscient, and omnibenevolent, why does evil exist? The test hypothesis offers a response. Experimenters allow evil because it's necessary for the test. Free will requires the possibility of evil choices. Moral development requires facing genuine moral dilemmas. Growth requires challenges and suffering. This doesn't fully resolve the problem. Why not test in ways that involve less suffering? But it provides a framework where evil serves a purpose, making it more comprehensible than purely gratuitous suffering. The scientific investigation. Can we test the test hypothesis? Is the test hypothesis scientifically testable, or is it unfalsifiable metaphysics? Let's examine possible empirical investigations. Looking for signatures. If Earth is a designed experiment, the designers might leave signatures, intentional or unintentional markers of their work. We could search for physical constant patterns. If constants like the fine structure constant or the cosmological constant encode messages or identifiers, we might detect them through precise measurement and mathematical analysis. Some researchers claim to find patterns, though these are controversial, such as the fine structure constant being close to a simple fraction or the speed of light in meters per second matching numerical patterns. Genetic code. Messages. If life was engineered, the genetic code might contain signatures, sequences that don't serve biological functions, but encode information. Some researchers claim to find mathematical patterns in genetic code, but mainstream biology considers these coincidental or misinterpreted. Astronomical arrangements. If the solar system was arranged deliberately, we might find anomalous patterns, orbits with precise mathematical relationships, planetary masses, or spacing encoding information, moons or asteroids positioned as markers. Most such patterns can be explained by physics or probability, but truly anomalous patterns, information rich, unlikely by chance, serving no natural function, would suggest design. Quantum experiments. If reality is a simulation, quantum mechanics might reveal computational substrate. Experiments testing. Bell inequality. Violations. Quantum entanglement violates local realism. Some interpretations suggest this indicates reality is non-local, or that information is fundamental. More precise tests might reveal whether quantum randomness is truly random or pseudo-random, suggesting a simulation's random number generator. Observer effect variations. If observation affects reality, because simulations optimize by rendering only when observed, we might detect asymmetries or patterns in how observation collapses wave functions. Hints that the rendering follows algorithms rather than being genuinely spontaneous. Computational limits. If the simulation has finite computational resources, pushing experiments to extreme precision or scale might reveal limits. Digital artifacts, rounding errors, unexpected quantization beyond known Planck scales. Historical analysis. If experimenters intervene subtly in history, statistical analysis might reveal anomalies, improbable convergences. Events that had very low probability occurring anyway might indicate intervention. For example, if crucial inventions or discoveries happened against large odds, or if near-extinction events were narrowly avoided through unlikely coincidences, patterns might emerge suggesting manipulation. Synchronicities. Mass synchronicity events, large numbers of people experiencing meaningful coincidences around the same time, might indicate experimenters making widespread adjustments. Timeline inconsistencies. If experimenters edit history, careful historical research might find inconsistencies, records that don't match, memories that contradict documentation, physical evidence incompatible with accepted timelines, the Mandela effect taken seriously as data. Searching for the experimenters. If experimenters are physical beings observing from locations in or near the solar system, we might detect anomalous objects. Surveys of asteroids, Kuiper belt objects, or interstellar objects might find artifacts, objects with regular geometric shapes, unusual compositions, or trajectories suggesting artificial origin. Surveillance technology. Extremely sensitive telescopes or detectors might find observation platforms, satellites, probes, or other monitoring equipment in solar orbit, on the moon, or elsewhere. Communication attempts. Some UAP might be communication attempts, or at least observable experiments or technology. Systematic study of UAP, as recent government programs are attempting, might reveal patterns suggesting intelligence. The non-response test. We could attempt to communicate with hypothetical experimenters, sending messages designed to be interpreted as recognizing the experiment's existence. For example, if you're observing us, we'd like to communicate. We recognize we might be test subjects. We request information about the test's purpose and conditions. If experimenters respond through UAP behavior, unusual signals, or other means, that's evidence for the hypothesis. If they don't respond, it's inconclusive. They might not exist, or they might maintain non-response as a test rule. The fundamental challenge. The core problem is that sufficiently advanced experimenters could make their intervention undetectable. Any anomaly we find could be explained away as natural. Any signature could be hidden. Any surveillance could be perfect. If they control our reality completely, especially if it's a simulation, they can erase evidence, adjust our perceptions, or ensure all observations appear consistent with natural processes. This makes the hypothesis unfalsifiable in practice. We can't definitively prove or disprove it. We can only accumulate evidence that makes it more or less plausible and decide how to weigh that evidence against alternatives. The ethical dilemma. Should we try to pass or deliberately fail? If we accept the test hypothesis provisionally, we face a strategic question. Should we try to pass the test, try to fail it, or ignore it entirely? Arguments for trying to pass. Survival. If passing means surviving existential threats, we should try to pass for our own benefit. Reward. Experimenters might reward success with continued existence, contact, or advanced knowledge. Moral obligation. If the test evaluates morality or wisdom, we should try to pass because it means becoming better, which is intrinsically good curiosity. Passing might reveal what happens next, contact with experimenters, understanding of ultimate reality, new phases of existence. Arguments for deliberately failing. Rebellion. If we're unwilling participants in an unethical experiment, failing might be moral protest against our treatment escape. Perhaps failing ends the test, and we're released from experimental conditions to some better existence. Revealing experimenters. If we deliberately create outcomes they don't want, perhaps by threatening to destroy ourselves, experimenters might intervene and reveal themselves, ending ambiguity. Null result. Making ourselves bad data might invalidate the experiment, forcing experimenters to acknowledge us as subjects rather than specimens. Arguments for ignoring the test. Uncertainty. We don't know if we're being tested, so optimizing for unknown criteria is irrational authenticity. The right response is living authentically according to our own values, not performing for imagined observers. Outcomes. Align. What we do for our own benefit, survive, cooperate, develop wisdom, likely aligns with test criteria anyway, so ignoring it produces the same outcomes as trying to pass psychological health. Obsessing over being tested creates anxiety and self-consciousness. Better to live normally. The paradox of trying. If the test evaluates authenticity or genuine development, trying to pass might cause failure. If experimenters want to see natural behavior, performing for them introduces artificial motivations. The way to pass might be to forget about the test and simply be. This is similar to the happiness paradox. Pursuing happiness directly often prevents achieving it, while living well for other reasons often produces happiness as a byproduct. Perhaps the test's design is such that trying to pass makes passing harder, while living authentically without regard for external evaluation is what passing looks like. The cooperative solution. Perhaps the best response is cooperation with ourselves and hypothetical experimenters. We cooperate by working together to solve shared problems, climate, poverty, disease, conflict, developing wisdom and ethics genuinely, not performatively, pursuing knowledge about reality, including the possibility we're being tested, treating consciousness, ours and others, as valuable regardless of external evaluation, creating meaning and beauty because they matter intrinsically. This approach serves us whether or not we're being tested. It makes existence better for us and potentially satisfies test criteria if they exist. It's a win-win strategy under uncertainty. Living with the hypothesis. Personal responses. Let's make this concrete. How might individuals integrate the test hypothesis into their worldview and daily life? The skeptical scientist. The test hypothesis is interesting speculation, but lacks empirical evidence. I'll continue living according to reason and evidence, pursuing knowledge, contributing to science, treating others ethically. If we're being tested, these behaviors probably align with success criteria. If we're not, they're still the right things to do. Either way, the appropriate response is the same. This person doesn't believe the hypothesis, but acknowledges it doesn't change what they should do. It's psychologically neutral, neither comfort nor anxiety. The anxious performer. If we're being tested, I need to be good. I must make moral choices. Work hard, contribute positively, demonstrate human potential. The experimenters are watching, judging. I can't fail them. I have to be better. This person takes the hypothesis seriously and feels pressure to perform. This might motivate positive behavior, but creates stress and inauthenticity. The test becomes a burden rather than a framework for understanding. The defiant rebel. If we're test subjects in an unconsented experiment, that's evil. I refuse to cooperate. I'll live selfishly, reject morality, undermine civilization. I'll make myself useless data. They can't use me if I'm deliberately corrupting their results. This person responds with anger and rebellion. This might feel emotionally satisfying, but produces harmful behavior that hurts the rebel and others. It's self-destructive protest against hypothetical experimenters who may not exist. The grateful participant. If experimenters created Earth and enabled my existence, I'm grateful. Life is a gift. Consciousness is precious. Existence is opportunity. I'll live fully, appreciate beauty, pursue understanding, treat others with compassion. I'm honored to be part of whatever cosmic project this is. This person finds the hypothesis comforting and inspiring. It provides meaning and motivation to live well. This seems psychologically healthy and produces positive behavior. The philosophical agnostic. I don't know if we're being tested. I can't know. That uncertainty is acceptable. I'll live according to my values, seeking truth, creating beauty, reducing suffering, building understanding. Whether experimenters exist or not, these things matter. The hypothesis is interesting to contemplate, but doesn't change my fundamental commitments. This person holds the hypothesis lightly, neither believing nor disbelieving strongly. They maintain epistemic humility while living purposefully. This seems balanced and mature. The spiritual synthesizer. The test hypothesis resonates with spiritual intuitions I've always had, that physical existence is temporary, that we're here to learn and grow, that consciousness continues beyond death, that our choices have cosmic significance. The hypothesis gives scientific language to spiritual truths. I'll continue my spiritual practice, meditation, ethical development, seeing these as alignment with test purposes or with deeper reality. This person integrates the hypothesis into existing spiritual framework. It validates their worldview and deepens commitment to spiritual development. Which response is best? There's no single correct response. People have different psychological needs, different values, different epistemic standards. The test hypothesis, like any metaphysical framework, can be integrated in ways that promote flourishing or in ways that cause harm. The healthiest responses seem to be those that don't generate excessive anxiety or performance pressure, don't lead to harmful behavior towards self or others, maintain intellectual honesty about uncertainty, produce positive motivations, seeking truth, compassion, growth, allow meaning and purpose while respecting an agency. The unhealthiest responses generate paralyzing anxiety or obsessive focus on being judged, justify harmful behavior as rebellion or nihilism, create rigid beliefs unsupported by evidence, diminish personal responsibility, blaming experimenters for everything, lead to passivity, waiting for experimenters to intervene rather than solving problems ourselves. The final question: does it matter? We've explored the test hypothesis extensively. Now let's address the ultimate question. Does it actually matter whether we're being tested? Arguments that it matters enormously. Existential stakes. If passing the test means continued existence, and failing means deletion or punishment, the stakes are as high as they could be. Everything depends on passing. Moral significance. If the test evaluates our ethics, every moral choice has cosmic importance. Our treatment of each other, our compassion or cruelty, our justice or oppression, all are being judged. This elevates the significance of ethics. Purpose and meaning. If we're test subjects, our existence has purpose beyond what we create for ourselves. We're here to answer experimental questions. This provides objective meaning in a potentially meaningless universe. Hope for justice. If experimenters evaluate morally, there might be ultimate justice. Good rewarded, evil punished. This provides hope that wrongs will be righted, that suffering hasn't been for nothing. Not alone. If experimenters exist, we're not alone in the cosmos. Intelligence exists beyond Earth, observing us, caring about outcomes. This is profoundly comforting for many people. Arguments that it doesn't matter. Behavioral equivalence. Whether or not we're being tested, the right behaviors are the same. Cooperate, be ethical, pursue knowledge, reduce suffering, create beauty. The test hypothesis doesn't change what we should do. Uncertainty persists. We can't know if we're being tested, so we can't optimize for test criteria with confidence. We're left making best guesses, which isn't different from how we live anyway. Intrinsic value. Ethics, knowledge, beauty, and consciousness have intrinsic value, independent of external evaluation. They matter because they matter, not because experimenters care about them. Autonomy matters. Living for ourselves, pursuing our own purposes, creating our own meaning, is more authentic than living for experimenters' purposes. Even if they exist, we should prioritize our autonomy. Unfalsifiable metaphysics. The hypothesis can't be definitively proven or disproven, making it more metaphysical framework than scientific theory. People have always debated such frameworks. Does God exist? Is there an afterlife? What is consciousness? Without resolution. Adding another doesn't fundamentally change the human condition. The synthesis. Perhaps it matters psychologically, but not practically. The test hypothesis provides a framework for understanding existence that some find meaningful and comforting, others find disturbing and anxiety-producing, and others find irrelevant to their concerns. It doesn't change what we should do. The behavioral equivalence argument is strong, but it might change how we feel about what we do. Some people are motivated by the idea of being observed and evaluated. Others are bothered by it. Still others are indifferent. Like religious belief, the test hypothesis matters to those for whom it provides meaning, purpose, or comfort, and doesn't matter to those who find meaning elsewhere, or who don't need metaphysical frameworks to live well. The appropriate response might be personal. Hold the hypothesis if you find it useful. Reject it if you find it harmful, or remain agnostic if you're uncertain. But don't let it paralyze you or prevent you from living fully, ethically, and joyfully in the reality you actually experience. Closing. The test you can't escape. As you settle into sleep tonight, perhaps you'll dream of cosmic laboratories where planets are terrariums and civilizations are experiments. Perhaps you'll dream of observers watching Earth from hidden vantage points, recording every human choice, evaluating our collective progress towards some unknown threshold. Perhaps you'll dream of living in a simulation where the rules can be rewritten, where glitches occasionally reveal the computational substrate, where the programmers sometimes intervene to adjust outcomes. Perhaps you'll dream of being a character in a story told for an audience you can't see. Your life meaningful as narrative, even if not as independent existence. Or perhaps you'll simply sleep, your consciousness dimming as your brain enters rest states, your body's automatic processes continuing without your awareness, your dreams reflecting the day's experiences, and your mind's ongoing processing of information. And that's fine too. Whether Earth is a test or not, you're here, now, conscious and alive. You face choices tomorrow that will affect yourself and others. You participate in systems, ecological, social, technological, that operate on scales far beyond your individual control, but that depend on countless individual choices, including yours, for their collective outcomes. Whether observers are watching or not, your choices matter. Whether you're being graded or not, ethics are important. Whether the test has an endpoint or not, existence continues. Consciousness experiences. Meaning emerges from the intricate dance of matter and energy that is you, and the relationships you build with other instances of that dance. Sleep well. Test subject or free agent. Experiment or autonomous being. Data point or ultimate value. Sleep well, knowing that whether reality is designed or accidental, whether you're observed or alone, whether your existence serves purposes beyond itself or is sufficient unto itself, you're part of something vast and strange and beautiful. Tomorrow, you'll wake and continue the test, or continue living if there is no test. You'll make choices without knowing their ultimate significance. Cooperate or compete with others also uncertain of the rules. Pursue understanding of a reality that might be simulation or substance. Create meaning in a cosmos that might be meaningful or indifferent. And perhaps that uncertainty, the not knowing whether you're tested, observed, evaluated, judged, or entirely free, is itself the test. Perhaps mature consciousness is defined by the ability to act wisely despite not knowing the ultimate context, to be ethical without guaranteed reward, to seek truth without assurance it exists, to create meaning in the face of possible meaninglessness. If you can do that, live well without knowing why you exist or whether anyone cares, then whether there's a test or not, you've passed something. You've demonstrated wisdom, courage, and authenticity. You've shown that consciousness can be valuable in itself, without external validation, without cosmic purpose, simply by experiencing, choosing, caring, and creating. So sleep well, and don't worry too much about whether you're being tested. Live well, be kind, seek truth, create beauty, reduce suffering. Whether experimenters are grading you or you're entirely on your own, these things matter. Good night, conscious being in an uncertain cosmos. May you dream of possibility rather than anxiety, of meaning rather than futility, of connection rather than isolation. And may you wake tomorrow, ready to continue the test, the experiment, the story, the journey, whatever this existence is, with courage, wisdom, compassion, and wonder at the extraordinary fact that you exist at all, that consciousness arose from cosmic processes, that the universe is experiencing itself through you. The test continues, or there is no test. Either way, you're here, and that's remarkable. Sleep well.